In October 2018, Lion Air Flight 610 plunged into the Java Sea. 5 months later, Ethiopian Airlines Flight 302 met the same catastrophic fate. 2 brand-new aircraft, 2 identical, inexplicable crashes, 346 lives extinguished. The aviation world reeled, searching for answers. This wasn't just a mechanical failure, it was a systemic breakdown, a deadly equation rooted deep within the very fabric of how a global titan designed, built, and certified its most important new plane. The real reason these planes crashed twice is far more complex than a simple defect, uncovering layers of corporate pressure, regulatory oversight, and a hidden truth that put profit before people. This story begins with ambition. Boeing, for generations a beacon of aerospace innovation, found itself in a fierce battle for market dominance. Its formidable competitor, Airbus, had launched the A320neo, a highly fuel-efficient narrow-body jet that was rapidly capturing orders. Boeing needed a swift response, a new generation of its best-selling 737 to reclaim its position. The answer was the 737 MAX, promised to be more efficient, more profitable, and an evolution of a trusted design. But to achieve this, they made critical choices that would redefine aviation safety. For decades, the Boeing 737 has been a workhorse of the skies, a testament to American engineering. But as the industry shifted towards more fuel-efficient engines, Boeing faced a dilemma. To compete with Airbus's A320neo, they needed to adapt the aging 737 design. This meant fitting much larger, more powerful engines onto a fuselage never originally intended for them. The physical constraints were immense, forcing engineers to mount these new, heavier engines further forward and higher on the wing, creating an aerodynamic challenge that would ripple through the aircraft's very stability. These new, larger engines, positioned differently, created an unintended consequence. The 737 MAX now had a tendency to pitch its nose up at certain angles of attack. This wasn't a catastrophic problem on its own, but it changed the aircraft's handling characteristics, making it feel different from previous 737 models. Crucially, Boeing wanted to avoid extensive, expensive pilot retraining. Pilots transitioning to the MAX were expected to require minimal additional instruction, simply a computer-based course. This desire for commonality would dictate the solution, a software system designed to mask these new handling quirks. Boeing's solution was the Maneuvering Characteristics Augmentation System, or MCAS. This wasn't a primary flight control system, but rather an automated enhancement designed to push the plane's nose down if it detected a high angle of attack. The intent was noble, to make the MAX handle like older 737s, thus avoiding the need for costly and time-consuming simulator training for pilots. But this automated fix, this hidden hand in the cockpit, would soon become a ghost in the machine, acting without warning, with devastating consequences that few could have foreseen. The core of this deadly equation lay in a single, fundamental design choice. The MCAS system, designed to counteract the new aerodynamic forces, relied on input from just one angle of attack, or AOA, sensor. This sensor, a simple vane on the aircraft's exterior, measured the angle between the wing and the oncoming air. If this single sensor malfunctioned, if it sent erroneous data to MCAS, the system would activate based on flawed information, without any cross-verification from a second sensor. A single point of failure, governing the fate of hundreds. Crucially, pilots were largely unaware of MCAS. It wasn't detailed in their flight manuals as a system requiring specific attention. It wasn't integrated into the minimal computer-based training provided for the MAX. Boeing believed MCAS would operate benignly in the background, a safety net that pilots would rarely, if ever, encounter. This deliberate omission, driven by the desire to keep training requirements low, stripped pilots of the knowledge and tools needed to respond when the system inevitably failed, leaving them unprepared for the nightmare that was about to unfold in the skies. On October 29, 2018, Lion Air Flight 610, a brand new 737 MAX 8, departed Jakarta. Just 13 minutes after takeoff, it plunged into the Java Sea. All 189 people on board perished. Initial reports were baffling: a modern aircraft, clear weather, experienced crew. But the recovered flight data recorder told a horrifying story. The plane's nose was repeatedly forced downwards by an automated system, despite the pilot's desperate struggle to pull it up. This was the first, terrifying manifestation of the MCAS flaw, a warning sign tragically missed by the broader aviation community. Analysis of Flight JT610's black box data was chilling. It showed that an erroneous angle of attack sensor was feeding false information to the MCAS system, convincing it the aircraft was stalling. In response, MCAS repeatedly commanded the nose down. The pilots, unaware of MCAS and its aggressive inputs, fought to save the plane, pulling the nose up, only for the system to push it down again, over and over. This wasn't a pilot error, it was a systemic trap, where a hidden system relentlessly worked against the very people trying to fly the aircraft. Following the Lion Air crash, the aviation world reacted, but perhaps not with the urgency required. The U.S. Federal Aviation Administration, the FAA, issued an airworthiness directive. This directive alerted airlines to potential AOA sensor malfunctions and the possibility of uncommanded nose-down trim. It advised pilots on how to react in such a scenario, using existing procedures. However, crucially, it did not ground the 737 MAX fleet. Boeing, for its part, maintained the aircraft was safe and that pilots could handle such anomalies. A perilous gamble was underway. Then, just 5 months later, the unthinkable happened again. On March 10, 2019, Ethiopian Airlines Flight 302, another 737 MAX, took off from Addis Ababa. 6 minutes into its flight, it too plummeted to Earth, killing all 157 people aboard. The similarities to Lion Air were chillingly immediate: a brand new plane, uncommanded nose-down movements, a desperate struggle by the pilots, and ultimately, catastrophe. This wasn't an isolated incident, it was a horrifying pattern, screaming for immediate, decisive action. The world could no longer look away. The second crash within such a short period, and the horrifying similarities to the first, ignited a global outcry. One by one, aviation authorities around the world began to ground the 737 MAX fleet. China led the way, followed swiftly by the European Union, Australia, India, and many others. Even the FAA, initially hesitant, eventually succumbed to immense international and domestic pressure, issuing an emergency order to ground all 737 MAX aircraft in U.S. airspace. The skies were suddenly empty of Boeing's flagship new plane, a stark symbol of a crisis of confidence. With the planes grounded, investigations intensified. And the findings were unequivocal: MCAS was the primary culprit in both disasters. In both cases, a single faulty angle of attack sensor fed erroneous data to the MCAS system, causing it to activate when it shouldn't have. This system then repeatedly pushed the aircraft's nose down, even as pilots desperately tried to counteract it. The hidden hand became that smoking gun, revealing a critical design flaw that had turned a safety feature into a deadly instrument, tragically binding the fate of 2 flights across continents. The angle of attack sensor itself wasn't a new or particularly complex piece of technology. It had been used safely on aircraft for decades. The vulnerability lay not in the sensor's individual reliability, but in MCAS's singular, unverified dependence on it. There was no redundant system to cross-check the data, no comparison to a second sensor to ensure accuracy before critical flight commands were issued. This single point of failure was a gamble, a bet against the odds, that ultimately cost 346 lives, proving that even reliable components can become deadly if implemented without proper redundancy. Why would Boeing, a company synonymous with safety, make such a critical design choice? The answer lies in the intense competitive pressure from Airbus. The A320neo was flying off the shelves, threatening Boeing's market share. To catch up, Boeing was under immense pressure to develop the 737 MAX quickly and cost-effectively. This race-to-market ethos permeated decision-making, prioritizing speed and minimal pilot retraining over a more robust, redundant system design. The corporate drive for quarterly profits cast a long shadow over fundamental safety engineering. Central to this rush was the desire to classify the 737 MAX as a derivatives of the existing 737 NG, rather than a wholly new aircraft. This classification was crucial. It meant airlines wouldn't need to put their pilots through expensive, time-consuming full simulator training. A simple computer-based course would suffice. This saved airlines money and made the MAX a more attractive purchase. But this cost-saving measure, driven by the bottom line, led directly to MCAS being hidden from pilots, a gamble on safety for the sake of market advantage and shareholder value. Adding another layer to this tragedy was the role of the Federal Aviation Administration, the FAA. The FAA operates a system called Organization Designation Authorization, or ODA. This program allows aircraft manufacturers, like Boeing, to act as delegated representatives of the FAA, performing inspections and even signing off on certain design aspects. While intended to streamline the certification process, in the case of the 737 MAX, it created a scenario where the regulator was relying heavily on the very company it was supposed to regulate. The lines of oversight became dangerously blurred. Critics argued this close relationship fostered a culture where safety concerns might be downplayed or missed in the rush to market. Were FAA designees, who were also Boeing employees, incentivized to flag issues that could delay certification or increase costs? This dual role raised fundamental questions about the independence and rigor of the regulatory process. The 737 MAX crashes exposed a system where the watchdog had, perhaps, become too deeply intertwined with the very industry it was tasked with policing, leading to a critical failure in the chain of command. The stark contrast in pilot training protocols highlights the severity of the issue. For previous 737 variants, pilots underwent comprehensive instruction. But for the MAX, driven by the cost-saving imperative, MCAS was largely omitted. Pilots were simply not informed of its existence, its purpose, or its potential for dangerous behavior if fed faulty data. This wasn't merely an oversight, it was a deliberate choice that left pilots flying a sophisticated, computerized aircraft without a fundamental understanding of a system that could, and did, take control away from them. This was a gap measured in lives. After the global grounding, Boeing finally acknowledged the severity of the MCAS flaw. Engineers worked feverishly to develop a software update. This revised MCAS now receives input from two angle-of-attack sensors, comparing their readings and activating only if both agree. If a discrepancy is detected, MCAS is disabled. Furthermore, pilots were given clearer controls to counteract the system. It was a comprehensive software patch, designed to restore safety and pilot authority, but it came too late for the 346 victims and the countless others whose trust in aviation was shattered. The financial fallout for Boeing was staggering. The 737 MAX grounding lasted for nearly 20 months, preventing hundreds of aircraft from being delivered. Boeing incurred over $20 billion in direct costs, including compensation to airlines for grounded planes, production slowdowns, and hefty legal fees. This doesn't even account for the lost orders, the cancelled flights, and the hit to their stock price. Once the world's leading aerospace manufacturer, Boeing faced a monumental crisis that dented its balance sheet and fundamentally altered its future trajectory, a direct consequence of prioritizing speed over safety. The impact extended far beyond Boeing. Airlines worldwide faced unprecedented disruptions. Flights were cancelled, routes were reshuffled, and passengers were left stranded, all due to the grounding of their 737 MAX fleets. This led to significant financial strain for carriers, many of whom had invested heavily in the new aircraft. The crisis rippled through the entire aviation ecosystem, affecting travel plans for millions and highlighting the interconnectedness of global air travel. The economic shockwaves were felt from the smallest regional airports to the largest international hubs. Perhaps the deepest cut for Boeing was the irreparable damage to its reputation. Once synonymous with engineering excellence and unyielding safety, the company's image was severely tarnished. Public trust plummeted. Passengers expressed fear about flying on the MAX, and the brand itself became a symbol of corporate greed and regulatory failure. Rebuilding that trust requires not just technical fixes, but a fundamental shift in corporate culture and an unwavering commitment to transparency and safety that must be felt, not just spoken. A legacy of innovation now carried a heavy asterisk. Imagine being in that cockpit, fighting an unseen force. The plane's nose relentlessly pushes down, your controls resist, and every emergency procedure you know seems to fail. You are battling an aircraft that is supposed to be your most trusted partner, but which has turned against you, commanded by a system you didn't even know existed. This was the terrifying reality for the pilots of Lion Air and Ethiopian Airlines. Their training, designed for older variants, offered no guidance against MCAS. It was a nightmare unfolding in real time, a betrayal of the most fundamental pilot-aircraft bond. Beyond the headlines, the financial figures, and the technical explanations, lies the devastating human cost. 346 lives, each with a story, a family, a future, extinguished in two avoidable tragedies. The grief of the families, the partners, the children left behind is unfathomable. These were not just numbers, they were individuals whose lives were cut short by a cascade of corporate and regulatory failures. Their memory serves as a stark, permanent reminder of the absolute, non-negotiable imperative of safety in aviation, a heavy burden that the industry must carry forward. Adding to the scandal were reports of internal Boeing employees, often referred to as whistleblowers, raising concerns about safety and production pressures long before the crashes. These voices, warning of cut corners and rushed processes, were reportedly ignored, dismissed, or even punished. This suggests a corporate culture that prioritized speed and cost over open communication about potential risks. When internal warnings are silenced, when the hierarchy discourages dissent, the consequences can be catastrophic, proving that a strong safety culture starts from within and must be actively nurtured. The real reason Boeing's new plane crashed twice wasn't a single flaw, but a devastating cascade of failures. It began with an aerodynamic necessity for new engines, leading to the MCAS software solution. This system was designed with a single point of failure, relying on one AOA sensor. Compounded by a lack of pilot awareness and training, and tragically enabled by regulatory oversight that was too close to the industry it monitored, the stage was set for disaster. This wasn't a singular misstep, it was a systemic breakdown, a perfect storm of design, culture, and regulation. The crisis prompted widespread calls for significant reforms within the FAA and other international aviation authorities. The ODA program, in particular, came under intense scrutiny, with proposals to increase independent oversight and reduce the industry's role in self-certification. The goal is to establish a truly independent and rigorous regulatory framework, one that prioritizes public safety above all else, ensuring that such a catastrophic breakdown in checks and balances can never happen again. This tragedy forced a critical re-evaluation of aviation safety regulations globally. Boeing has embarked on a long and arduous journey to rebuild trust. This includes implementing the crucial MCAS software fixes, enhancing pilot training requirements to explicitly cover MCAS, and reforming some internal processes to prioritize safety. The 737 MAX has since been recertified and returned to service globally, but not without extensive scrutiny and new protocols. Yet, the path to fully restoring its reputation and the confidence of the flying public is ongoing, a testament to the profound impact of these tragedies and the scale of the company's challenge. The 737 MAX crashes stand as a chilling lesson for the entire aerospace industry. They underscore the absolute imperative of prioritizing safety above all other considerations, speed to market, cost-cutting, or competitive advantage. Rigorous independent testing, transparent communication with pilots, and unwavering regulatory oversight are not optional, they are the bedrock of safe aviation. These tragedies forced a global reckoning, hopefully ushering in an era where lessons are truly learned, and the human cost of negligence becomes an unshakable deterrent against future compromises. In the shadow of Boeing's crisis, Airbus, its main competitor, offered a contrasting philosophy. Airbus aircraft typically feature highly integrated fly-by-wire systems with built-in redundancies, often employing multiple sensors and computing units to cross-check data before executing commands. While no system is foolproof, Airbus's approach emphasizes layers of protection and clear pilot feedback, rather than a single automated system operating in the background. This philosophical divergence in design, especially regarding critical flight control, became a key point of comparison in the wake of the 737 MAX disasters. This core difference encapsulates the contrasting engineering philosophies. On one side, Boeing's initial MCAS implementation relied on a single AOA sensor with limited pilot awareness and override capability. On the other, the preferred modern approach emphasizes multiple, redundant sensor inputs, constant cross-checking of data, and transparent pilot integration with automation. This side-by-side comparison reveals where critical design choices ultimately failed. The lesson is clear: for systems with potentially catastrophic consequences, redundancy isn't a luxury, it's a fundamental requirement for preventing disaster. The relentless pressure to rush the 737 MAX to market, driven by fierce competition and shareholder expectations, proved to be a critical contributing factor. Every decision, from the engine placement to the software fix and the limited pilot training, was influenced by the desire for speed and cost efficiency. This created a perilous trade-off, a compromise between rapid deployment and robust safety measures. The crashes serve as a grim reminder that in industries where human lives are at stake, the cost of cutting corners is immeasurable, and the allure of short-term gains can lead to long-term devastation. Even with the 737 MAX back in the air and Boeing implementing changes, lingering doubts persist. Questions about the true independence of aviation regulators, the effectiveness of corporate governance, and the industry's ability to prevent similar catastrophic compromises remain. The journey to fully restore confidence is far from over. These tragedies highlight the continuous vigilance required in aviation safety, a constant battle against complacency, against the pressures of commerce, and a perpetual commitment to the ultimate responsibility, safeguarding every soul that steps aboard an aircraft. The lessons from the 737 MAX tragedies echo the timeless wisdom of industry leaders and pioneers. They remind us that aviation, while a marvel of human ingenuity, demands an unwavering respect for its inherent unforgiving nature. As Antoine de Saint-Exupéry, the famous pilot and writer, once articulated, the skies are merciless to carelessness, incapacity, or neglect. This profound statement serves as a powerful testament to the ultimate responsibility of aircraft manufacturers, regulators, and pilots alike, a sacred trust to uphold the highest standards of safety for every single flight. The real reason Boeing's new plane crashed twice wasn't just a technical glitch or a single faulty component. It was a complex tapestry of systemic failures, a rushed design, a hidden software system, inadequate pilot training, and deeply flawed regulatory oversight. It was a tragic betrayal of trust, where the pursuit of market advantage overshadowed the paramount commitment to safety. As the world moves forward, the echoes of those 346 lost lives must serve as a permanent, solemn promise: never again will the industry allow such a devastating combination of factors to endanger the skies.